Tray containing 0.2 kilograms of water at 20 degrees is placed in a freezer. The water has completely turned into ice at 0 degrees Celsius in 40 minutes. Calculate the power of the freezer. The first thing we need to do here is draw a picture. So firstly we have some water at 20 degrees in a tray, and then as you place it in the freezer, it's going to cool down. It's going to cool down to its freezing point, where it's water at 0 degrees. And as you cool it further, it will change state from water at 0 degrees to ice at 0 degrees. So this part will use a specific capacity formula, and here we'll use latent heat. Okay, so the part that requires the energy that's absorbed from the sample to cool it down is 0.2 the mass times the specific capacity of the water times the change in temperature, 20 minus 0. So I'm taking the positive value so that I don't get any errors with signs, and then I need to change the state. That's just the mass of the water times the specific latent heat of fusion. And you show my work out clearly because it's very easy to make mistakes on this question. And then finally, that's it. Okay, so the total of that is, it turns out 82800 joules. And if it takes 40 minutes, I just need to do power equals energy over time. (40 minutes times 60 seconds gives me 4.5 watts. Okay, state an assumption you made in your calculation. So here we've assumed firstly that the tray itself has no specific capacity or negligible specific capacity, otherwise we'd need to absorb some energy from the tray itself to cool the tray down as it cools down with the water. Also, we've assumed that there's no energy transfer from the surrounding to the tray and water, or from the tray and water to the surrounding. So we've ignored all that. It's just whatever the freezers come 100% efficient. Okay. So what about if you want to take into account the fact that the tray does have specific capacity, and the fact that it needs to also be cooled down because it starts off at thermal equilibrium with the water. So it starts off at 20 degrees with the water and it cools down to 0 degrees with the water. So if we want to take this into account, obviously it's not changing state, we just need to use a specific capacity formula for the tray as well. So what we'll need to do is we'll need to add on the energy that needs to be absorbed from the tray. The mass of the tray is 0.05. The specific capacity of the tray is 1100 times the change in temperature is going from 20 to 0. And that gives us a new energy of 86900 joules. And that leaves, if you divide that by 40 minutes times 60 seconds, that gives us a new power of 35.0 watts.